Hi, I'm Marty Sullivan, a grad student in information science. I put together this idea of a project where we could take a weather model that is run by the National Weather Service and try to assess the accuracy of that model at a more local level. So, what I did was I looked at the data that we could use to do that, chose a specific model to look at, and also looked at the observation network that we could use to actually assess the accuracy of the model. The model we decided to look at was the National Digital Forecast Database, or the NDFD. This model is created by the National Weather Service and is a very high resolution model for the contiguous United States. There are many variables available, from maximum and minimum temperature to hourly temperature to relative humidity, cloud cover. There's really an abundance beyond what we wanted to look at for this project. What we decided to look at was the amount of liquid precipitation that was forecasted between 24 hours and 48 hours ahead of time. In order to actually assess the accuracy, we have to compare the forecasted amount of precipitation to an actual observation. So I took the observations from the Global Historical Climatology Network, or the GHCN. This network of weather stations exists across the planet. So we looked at ones specific to New York State and decided to assess the accuracy of the model just within New York State. The really cool thing about weather data is it's very readily available across the internet, usually from NOAA when you're talking about the United States. I access the raw data for all of these data sets, which are kind of well documented, but not really. So you sort of do have to dig in and figure out like what each file has in it and how you have to, download that file and then parse the information within the file and then actually do something with it. So as you can see, there's a lot of different variables and inventories that just the GHCN has. We had to figure out, first of all, what stations do we want? So I was able to figure out from all of these inventories and station inventories that we could figure out, okay, what stations have the data that we need for the years that we need, which we decided to go just the last 2 years. So October 2015 to the end of October 2017. Once the inventory was figured out, it really just came down to writing some code that would pull down the data. So basically go through and download the GHCN data. Those were in yearly files, so those were pretty easy to retrieve. We just downloaded the years for 2015 through 2017, and then pulled the station IDs out of there that fell within New York State. That gave us the latitude and longitude of the positions of those stations. Then we were able to take that inventory of station IDs and actually pull out the observations for precipitation for each of those locations for every day. So the GHCN are daily summaries, so that we were basically just looking at a per day forecast, and that 24 and 48 hour ahead of time made it easy to do that. Now, the NDFD is a lot more complicated in the way that you have to retrieve the data, because they store a file for each variable, and there are basically 24 forecasts per day because it is an hourly forecast. Now, at least for the quantitative precipitation, which is what we were looking at, that's only done every 6 hours, so that reduced the number of files by a lot, but you still had to choose, okay, well, what time do we have to start. So we chose the file that goes at midnight the day before that we're interested in looking at, and then downloaded all of the files for the following, day from 24 hours to 48 hours ahead of time, and then summarized the total for that day, and then compared it to the actual observation at each station. So that involved, pulling out the station location within the grid in the forecast, and then actually comparing the observation to that forecast at each day. And then once you have that comparison, you can run basic statistics on it to figure out, okay, well, how accurate was it? And then you do the statistics for every day of the year, and then you can have an average, an average accuracy for that station over that 2-year period. Then the final step was to create a shapefile that had all of that information in it. So I projected the latitude and longitude coordinates of each station to NAD 83, UTM 18, and then put an entry for that each station within the shapefile, and then the attribute table for the shapefile had a column for the accuracy of each station, and then the 2-year total of liquid precipitation, and then also the daily average precipitation for each station. So with that data, my other team members were able to create the maps that they will present and create some cool visualizations of that data that hopefully would be useful to someone who would want to assess the accuracy of this forecast for their own property within New York State.